WebMCP is an upcoming feature that makes any site easier for an AI agent to use because it gives the agent access to developer-defined tools like an MCP server instead of having to scrape HTML to understand how a site works, saving you lots and lots of tokens. But WebMCP only works inside a live browser tab, which most harnesses like Claude Code or agentic workflows just don't have access to unless you connect them to Firecrawl, which can take care of the whole thing using its Interact endpoint. Let's see how to do this, and before we do, make sure you hit subscribe. Websites are made for humans, not agents. They have images, animations, accessible elements that are not really useful if you want AI to book you a flight. So a bunch of engineers from Google and Microsoft came up with a proposal for WebMCP, which works by a developer registering tools for actions an agent can take on a website using JavaScript or HTML. So they'll have to define a name, description, input schema, as well as the logic that's needed for the tool to work, similar to regular MCP. So booking a flight is a single tool call instead of the agent having to find all the inputs, fill them in, and click on the submit button. Much less work. But there are some limitations, because right now there's no support for agents to call tools in a headless browser, and clients, so the agent needs to use the browser directly, meaning browsers have to have their own onboard agent in order to use this properly. This, of course, isn't great if you have a bunch of skills, tools, and workflows already in a harness like Claude Code that you want to use with WebMCP, or if you've created a custom agent using a popular framework that you want to benefit from some of these token savings. Now, I'll give my thoughts on WebMCP later on in the video, but for now, Firecrawl can help you get past most of these issues with its Interact endpoint, which spins up a browser in the cloud for your agent to control with a prompt, or you can execute code directly on the cloud browser, which is perfect for this scenario. So let's go through how that could work. So to get started, I'm using this basic website from Google's WebMCP examples repo. You may have seen this before, and it allows you to fill in a form and submit to book a table at a fake restaurant. Now, right now, if I have a look at the MCP tools enabled, we don't have any, and I've been able to view this by first enabling the WebMCP for testing inside Chrome and then downloading this Chrome extension. So let's go through how we'd give this site a basic MCP tool. And in order to do that, I've installed a WebMCP polyfill, which I'll add a link to in the description. And after initializing the polyfill, I've registered a tool with this name and an input schema containing all the inputs on the form, so name, phone, date, and so on. And at the end of that, I have an execute function that runs the actual logic, which is adding all the required inputs from the model to the form on the site. Then it validates the form for errors. And if there aren't any errors, it shows the reservation modal and gives the agent the reservation text. And now we can see these tools appear on the site. And if I had a Gemini API key, I could write a prompt for it to fill in the form. But if I try it with Claude Code, even with MCP, what it does is it scrapes all the inputs on the website, then goes through each input to fill it in with a value, and then takes a screenshot with computer use to validate that the form has been filled in. And you can imagine just how many tokens this whole process will take up. Now let's try and do it with Firecrawl. But before we do, let's do it with Agent Browser locally on my machine to explain how Firecrawl will do it on the cloud browser. So this is a basic bash script that uses Agent Browser's eval to execute JavaScript code onto its headless browser. So what this does is it looks for the document context object in the code, and if it does find one, it gets access to all the tools that are available. And now once the agent has access to this, it can execute the tools, calling the tool name with its arguments. JSON passes the arguments and then executes the tool. So here in Claude Code, I've asked it to use that script to see what tools are available on localhost 3004. And what it returns is the exact tool that I coded, which is book table Le Petit Bistro with the required arguments, name, phone, date, time, and guest. So with this information, I asked it to book me a table for next week Thursday. It asked me some questions, so verified next week Thursday, and asked for the number of guests. And then after that, it ran another shell command, passing in all the relevant info before finally booking my table. So no need to scrape or take screenshots, and all of this was done incredibly quickly. But the problem with Agent Browser is that it needs to install Chromium and Playwright locally in order for it to work. And depending on the agent or where it's being used, say you have an agent that needs to run in a work environment where you can't install these things, or it's an agent that runs online or in a CI pipeline that has these restrictions. In many cases, it's much easier to use Firecrawl with the Interact endpoint, which gives you access to a cloud browser. So here I've written some code making use of the Firecrawl Node SDK, which works with or without an API key. And what it's doing here is it's first scraping the page in order to get the scrape ID. And then I'm using the Interact endpoint to keep the browser session open that was used for the scrape. Now, Firecrawl does have a browser endpoint that doesn't need to use scrape in the first place, but Interact is better for agentic workflows. And here I've written some code that I want executed on the cloud browser. The only difference here between the agent browser script and this code is that I'm using Playwright's eval instead of agent browser's one. And this works because Firecrawl's Interact supports writing code with Playwright for Node, as well as Playwright for Python and Agent Browser. But Agent Browser uses Playwright behind the scenes, so it makes sense just to write Playwright code directly. And from here, this code is identical to what was used inside the Agent Browser script. Then we JSON stringify the code to send it reliably over Firecrawl's transport before specifying the language. Then below that, we have some more code to check if tool name is in the CLI argument. And if it is, we run another interact with the same scrape ID, which executes the tool with the specified arguments. Now, if I tell Claude to use my script to tell me what tools are available on this URL, and while Claude is running, if we take a look at the Firecrawl dashboard under Interact with Page and go to our sessions, we should see a new session show up that will temporarily spin up our website, which again, it finds the exact tool before listing out the required and optional fields. From here, I can ask it to do anything like book me a table for next week Thursday for 2 people. I forgot to add the time and phone number, so I asked it to make them up. And then after that, it booked it using a single shell command, exactly like the Agent Browser one, but I didn't have to install anything locally. This all worked in the cloud in under a minute. So that's basically how you can use WebMCP today with your current agentic workflows in Firecrawl. Now, I will admit my implementation isn't exactly perfect because right now, if you use the declarative HTML approach with WebMCP, then it will work because you have to use a polyfill, which uses JavaScript behind the scenes. But when WebMCP is officially released and Chrome supports the native approach, then my script will have to be updated in order to search for specific HTML tags. Also, the proposal is very new and anything could change before it's released. For instance, they've changed Navigator recently to Document, which means there could be more changes in the future. But if I'm being honest, I'm not really sold on WebMCP. So on paper, it's a great idea. But the fact that Firefox and Safari have no interest in implementing it means that this feature is more for AI-specific browsers like Deer, Comet, and Atlas instead of regular browsers that most people are using. And in my experience, right now, most agents are scraping the web to get information. They're not really browsing a live site. So I'm not sure how long it's going to take for people to move over to agent browsers, if that will even happen. So I think they really need to invest in their headless approach. But if that never happens, then there's always Firecrawl, which can get past this. And if you use this code, you can get 500 extra credits if you sign up. Speaking of Firecrawl and agents, if you want to see how I gave Claude Code the ability to read PDFs, Excel spreadsheets, Word documents, and 6 other different file types, then check out the next video, which goes through the Firecrawl parse endpoint.